So, just to kind of make I'm going to draw a circle here, but draw a parabola-ish shape. When you first learn about parabolas in Algebra 1 and even Algebra 2, and even when we talked about them again this year, right, we always talk about that point, the vertex, and we're still going to talk about the vertex. So we're going to talk about that you can define a parabola that every point on that graph is equidistant from a line, and that line will always be behind the parabola. So if your parabola is opening up or down, right, like your line is always going to be horizontal, and this is going to be your directrix. And I'm just winging this, so it's probably not going to look super accurate right now. And your focus is always a point inside the parabola on the same line as the vertex. So like here's the vertex, your focus is going to be some distance. I'm just going to write that focus there. And I was reading last night from the college algebra class, reviewing the conic sections that they're about to have a test on. And I was reading that, think about satellite dishes. You could kind of talk about like their parabola shape. And the reason that you have shapes like that to collect whatever we're talking about satellite dishes. But it said like everything that comes and bounces off a parabola, it goes to that focus. So that's why it's called a focus. And I kind of thought that was pretty cool. And there was a picture about it. I had like waves coming in, whether it's light or whatever, radio waves. It comes in and bounces off, and they all go to that focus, which is why it's called the focus, which I thought was kind of cool. What's really cool that's not in my picture very accurately is that this distance and this distance will always be the same. So this distance and this distance, I'm just going to kind of mark them. We'll actually also after I get it. Will always be the same distance. And we're going to talk about this equation. There's this p value, and that distance will always be p, and that's how we can use that to find our values there. All right. So I did one that opens up. We could also do one that opens side to side. So if it opens side to side, think about your directrix is going to be a vertical line. So this is now going to be my directrix. And my focus is now going to be inside the parabola as well. And so if you understand directrix is behind it, focus is inside of it, it's easy to be able to graph these without feeling like you have to memorize a million things. Okay? So we're going to write out a bunch of stuff for a vertex at 0, 0, and then we're going to expand that for if the vertex is not at 0, 0. It looks a little scarier when it's not at 0, 0, but I think it's helpful if you understand this, then you can just say, oh, I started my vertex, and then I moved to the units. And so, again, I put some pictures here for you because the formulas are different depending on which way it opens. If it opens up or down, then your x is going to be squared, just like we've always dealt with quadratics. But if your equation has a y squared in it and x isn't, then your parabola is going to open side to side. And so that's step one, is you have to kind of realize which equation that you're dealing with. So if x is squared, and notice there's this p value that I was talking to you about, write that out in a minute, but p is going to be our distance from our vertex to our focus, or from our vertex to our directrix. So this one is going to open up or down. How do you think you'll be able to tell if it opens down instead of up? Yeah, if it's a negative sign in there, right, then it's going to open down. Up. If our vertex is at 0, 0, then our focus is just going to be up p units. So that means our focus is going to be the point, still going to be at 0, but it's going to go up p units. What do you think? You think we should do this whole column first and then switch over here, or do them both at the same time? Okay. Maybe you could draw lines there if you want to try to keep it organized. I don't know. The directrix is an equation. It's an equation that always sets outside of the parabola, and it's p units the other way. So if the focus is 0p, the directrix is a horizontal line, so it's going to be the equation y equals negative p, but it's the opposite way. The axis of symmetry is that line that you've talked about forever that cuts the parabola in half, that makes it symmetric. When we graph this, I don't really use the axis of symmetry, but just to kind of remind you, the axis of symmetry goes through your vertex, so that would be just the y-axis, right? Like it would be the line next to the The focal length is always going to be just that p-value, like the distance from the vertex to the focus. So your focal length is just p. Your focal width is what's going to make it easier to graph, and like it comes from this Latin word called the latus rectum, and it in our Algebra 2 book it always uses that, but we don't do Algebra 2 book, right? We used to do this in Algebra 2 in precalculus. Now we only do it in precalculus. But we're going to talk about this focal width makes it easier to graph. Really small focus here, but the focal width is the line that goes through the focus and it touches either side of the parabola, and it's always going to be the absolute value of 4p, which means you can kind of tell it by when it's in this form, and it's going to be a really quick, easy way to graph. So we're going to say it's the absolute value of 4p. So that p value is going to come in handy as we do this. Okay. So same thing on this side. Hopefully you're going to see what changes is that now x is not squared, y is, which means that this is going to open left or right. And again, the same thing occurs. Yes. I don't know. Yeah. Like, where's the 4 come from? Right? Like, why is it? Like, whatever p is, you multiply it by 4, and that always gives you something. But I don't know what it is. But I can. Maybe we could draw a right triangle. My focus is always going to be perpendicular to here, and this is p. Sorry, I was trying to think like this would be 2p, but that's not really good. All right. So on this one, the focus is now going to be the other direction, right? So now it's going to be moved horizontally p units. So that's going to be the point p0, not 0p. The directrix is behind it. So now the directrix is a vertical line, and it's x equals negative p. So it's all about knowing which way you're going. Is it left and right? Is it up or down? The axis of symmetry is now the horizontal line through the vertex, which in this case is y equals 0. Right? Notice our x's and y's are just changing places. The lengths are the same. The focal width is still p. The focal width is still the absolute value of 4p. I guess we should say that this is also absolute value for the same. If you understand what p is, and you understand how the focus is inside and the directrix is outside, you can do these without needing all this stuff, right? It helps to kind of graph it out and think about it even if you're not supposed to. And then the only thing that we're going to change is, what if the vertex is not at 0, 0? It just means we can throw in the x minus h, the y minus k, everything else stays the same, all right? So I really want you to not be dependent on staring at these papers all the time as you do the problems, because you're not getting these on your test. Because you don't need them on your test. You just need to understand which way it opens and what p means, and you can do these problems. Okay? So let's practice. Just like with the circle, like with all of these conic sections, step one is you want to make it look like the form of the equation, which is that the x or the y squared is by itself on this side, right? If you look back at both of these, the x squared by itself, the y squared by itself. So the first thing I see on this is I want to move this 5, right? So I would get 16 over 5x. So I'm going to write up here my equation. Y squared equals 4px. If you're going to list all this stuff, well, maybe not the vertex. What's the vertex on this? It's just 0, 0. There's nothing with the x or the y added or subtracted, so that's the easy one for now. But to do the focus, the directrix, and the focal width, all of those have p in them. So that's where you have to be able to find p. So 4p is going to equal whatever's in front of x. So I can say I know 4p equals 16 over 5. And again, I picked one that's kind of ugly. It's much nicer if that just equals 16. It'd be much easier to find what p is. But all I'm going to do is do algebra here, right? I'm going to divide by 4, which is the same as multiplying by 1/4. So I can say that in this problem, I know that p is 4/5. And you can check. 4/5 times 4 gives you 16/5. If it helps, make a sketch of the graph. It doesn't have to be perfect, but because y is squared and x isn't, I know that this one's opening side to side. It's starting at 0, 0. And my focus is going to be p units away from that, right? So the focus is going to be in here. So I don't think about the formulas over there. I think about, oh, it's p units over. So the x has moved p units. So that's going to be 4/5, but the y is going to stay at 0. Always. Because if you know p, all of these other equations come from p. The directrix is an equation. And again, it helps me to kind of graph it out here, that if this is the parabola, if I move over p units, I know that it's going to open like this. So I know my directrix is behind it, which is what tells me it's the equation x equals, and it's p units that way. So if I go backwards 4/5, that's the equation x equals negative 4/5. And the focal width, that's going to be how far it is from here to here. That's how we're going to graph it in a minute to help us. It's just going to be 4p, which is already here, right? That's what 4p is. So the focal width is just 16 over 5. If it's in standard form, it's what's in front of the variable that's not raised to the power. Questions where I got all that. Because if whatever p is, you go the opposite way p units. Like that's just our formula. So this should be negative p, this should be positive p. So whatever p is, we're just going back that much from the vertex. So let's talk about graphing these and why maybe using this form to graph a parabola, using the focus to help us, makes things a little bit easier. So again, step 1, you want to make sure it looks like the form on that equation, which is the y squared by itself, which in this one it is, right? It's just like number 1, the y squared by itself. So this is 4p, which means this one's a lot easier, much easier to graph. If 4p equals negative 8, then p has to equal negative 2. So every time, step 1, get the squared term by itself. Step 2, find what p is. And then you can graph this without ever having to make a chart if you know which way it opens and you use your focal width. So, my vertex, you agree my vertex is 0, 0 again? Always not so far. So 0, 0. Since y is squared and x isn't, should this be opening side to side or up and down? Side to side. My focus is p units away from my vertex. Since p is negative 2, should I be going left 2 or right 2? Because it's negative, right? And if you look back at our formula for focus, it's p0, which means my focus here would be negative 2, 0. So I'm going to go back here, and that's going to be my focus. If it's negative, it's going to open to the left, if it's to the side. If it's negative, it's going to open down, if it's up and down, okay? And just to show you the directrix, you don't have to draw the directrix to graph it, but I just want to show you it. The directrix is the equation p units the other way. So the other way from negative 2 would be positive 2, so the directrix would be the line x equals positive 2. And if you look at our formula, it's x equals negative p. Our directrix is negative of negative p, with x equals positive 2. So here's where the focal width is amazing, because the focal width goes through the focus and it touches the side of your graph, which means you don't have to make an XY chart on any of these. My focal width is the absolute value of that number in front, which in this case is 8. Yes? 4p, absolute value. So that means that the focal width here is going to be 8, and since a parabola is symmetric, I'm just going to go half on each side. So if I go 4 this way in the focus and 4 this way, you read it, that makes a line that's a length 8. Those are 2 points on your parabola every time, which is why the focal width is very useful, because now I can make a very accurate graph without ever having to make an XY chart. So you graph your vertex, you graph your focus, and whatever your focal width is, you go halfway either way, and that will always be your equation. You just have to make sure it's opening the right way to do that. Questions about that? You don't really need a directrix to graph it. Like, you don't. What they're saying in the definition, like, so if you didn't graph your directrix, that's fine. I'm not going to mark you wrong. But the definition of a parabola is that every point on this parabola is equidistant from the focus and the directrix. And remember, when you measure distance, it has to be perpendicular, so it's kind of weird to try to draw that in. But, like, if you measure this distance is 4, right? This distance is also 4. And so every distance here is the same thing. So remember, with a circle, it's defined as every point on the circle is equidistant from that one center. For a parabola, every point on the parabola is equidistant from both that point and the center. So that's what makes it kind of go out wide like that. So, but you're right. If you have to graph it, unless it says specifically to graph your directrix, you don't need the directrix to graph it. Okay? Are there questions on that? Be really careful, though, on questions like number 3, because it's really easy to do this wrong, because this is not set up properly for us, right? Do you agree with that? Because we want the squared one by itself. So this is where the first thing you need to do is I would multiply both sides by -6, because I want to get the x squared by itself. So if I multiply both sides by -6, then I'm going to get x squared equals -6y. So you always want the squared one by itself. Right, you could divide by -1/6, but that's right. So do the reciprocal, I just easier. So again, Get it in the right form. The second thing that I do is I look at it and I say, okay, x is squared, so this should be opening up or down, and maybe even you can tell me which one. Is it going to open up or is it going to open down? Down, because it's negative. So make sure your graph matches what you know it's supposed to look like. And then find P. How am I going to find P? I'm going to set 4P equal to whatever's in front of that number. So 4P equals negative 6. So divide both sides by 4, and I get that P equals negative 3 over 2, or negative 1.5. Not as great as negative 2, but not good. So again, graphing it, you just have to graph your vertex, your focus, your focal width, and you should be able to graph that equation. So again, my vertex is 0, 0. If you're not sure which way it's going, if you know the formula, that this is going to be P units away, but it's up or down. So since it's negative 3/2, that means I should go down 1.5, which is what tells me that it's opening down. I'm going to graph the directrix again just because it's kind of a new idea here. The directrix is the line the opposite way, P, so 1.5 this way. The line ish. Which one? The focus? Well, the directrix is positive 3/2, right? Because it's the opposite way. Your focus is P units away. So if it's negative, your focus is negative. So that's going to be 0, negative 3/2, because it's 0P, whatever P is. Your directrix is the opposite sign. So if P is negative, then your directrix is going to be positive, because the opposite of negative 3/2 is positive 3/2. And then remember that this number is your 4P, absolute value of 4P. So it's really nice because we know that this is just going to be 6, right? Positive 6 is absolute value. Which means all I have to do to make a really nice graph is from my focus, I'm going to go 3 units to the left and 3 units to the right. 3 plus 3 make my focal width of 6. And I'm going to make my parabola. It is 1/2, yes. Okay, yes, so you can do 1.5 if you like the decimal over the fraction. Yes, if you find your focus, right? Yes. And you can do the same thing when it's not at 0, 0. You just have to set that for maybe. So the first page, I wanted us to write those out to talk about it. This next slide, I gave you all this stuff, and I agree that it looks kind of scary, like that's a lot of stuff to memorize, but I just want you to look at this part first. These are my 2 equations. The only thing I've changed is instead of the vertex being at 0, 0, the vertex is at HK. So instead of being able to start at 0, 0 every time, we're going to start wherever the vertex is. And then, do not feel like you have to memorize all of this stuff, because it's the same idea of your directrix will be P units away from your vertex in the opposite direction, right? So instead of just being negative P, it's K minus P. Your focus, if it's opening up or down, will still be up P units, or down if it's negative P units. So again, all we're doing is moving the focus P units away, and your focal width is still 4P. So I will tell you, I don't have these exact equations memorized, but I know what P is, and that's how I do this problem. I start at my vertex, and then I know I'm moving P away. That's what I recommend you to do, because if you try to memorize all this stuff, it's going to be easily mixed up, and there's no need to feel like you need to memorize it all. So again, this is up or down. That's why I just gave it to you, so hopefully you can memorize it. Same thing on this side. When y is squared and x isn't, all we've done is put in the vertex hk, just like the center of a circle. And again, we've just moved the focus p units left or right. We've moved the directrix p units the opposite way. Your focal width is still 4p. So we're going to do an example of this, and I'm going to show you how you don't have to use this as a crutch, because you're not going to have this on your test. So don't be using it as a crutch. By all means, use it to help yourself to check your answers. But don't feel like you have to have this in front of you to do these problems, because you don't. You just have to understand where's the vertex, what is p, what is the focal. Step 1, get x squared by itself, right? So the first thing I'm going to do on this is I'm going to just subtract that over so that it looks like the form that we like. Yes, that's what I'm going to do next. And I'm going to show you how you can use the graph to find your answers as opposed to using the equations. So yes, what would the vertex of this be? H and K, be really careful sometimes when Y is first, it's easy to mix those up. But H is with X, Y, or K is with Y, just like with the circle. So opposite signs still, right? So 1, -2. Anybody with me on where I got that? Just like with the circle we did yesterday. So I'm going to graph that. The vertex is 1, -2. Which way should this be opening, up or down, left or right? Which one, up or down? Because x is squared, it tells me it's up or down. Because it's negative, it should be opening down. Right? So make sure you're making your picture look like that. Just like the last ones, when it was 0, 0, can I find p? Right, that's still 4p. So I can say 4p equals -8. So are you with me that p equals -2? When it opens down or left, you're going to always get a negative p value. So here's where I say you don't need the formulas, because you can just sketch the graph and then find the exact point. If this is my vertex, I know that p is going down, right, 2 units. So if I go down 2 units, that's my focus. That's why you have to know that it's opening down, or you have to know that it's up or down, and that negative means down. So could I say, by just looking at the graph now, right, what did we do to find the focus here? We've left the x the same, so the x is still 1, and we just moved it down 2 units. So it's still p units away, but it's p units away from -2. So -2 minus 2 is why you get the point -4. Or you can just look at your graph and say, oh, that's 1, -4. No need to feel like you have to memorize that equation. The directrix is the line behind the graph 2 units the opposite way. So here is my point. Now I'm going to go 2 units the other way, and that's going to be my directrix. And again, even if you don't graph it, you can just kind of see from the picture that it's just 2 units away. So it's the line y equals, you go 2 units up from -2, that's why you get y equals 0. So you have to start at your vertex to get those values. And we're going to graph it the same way with the focal width. What's my focal width on this one? (4p), right? 4p is my focal width. It's absolute value. It's just this number here, 8. So it means through my focus, I'm going to go 4 this way, And I'm going to go 4 this way, because 4 plus 4 gives me 8. And I'm going to sketch that graph. So it's why I start with the vertex at 0, 0, because I feel like it's easier to kind of think about what P does to that graph. And then all we're doing is changing where it starts. So instead of starting at 0, 0, you start at H and K, but then you still do the exact same thing. You move P units inside the graph for your focus, P units outside for your directrix, and you graph your focal width. Yes. That's what last year, there were, Ariel Higgins thought, she was like, this is so much easier to graph. Why wouldn't we want to graph like this? I think the big reason is if it's not in this form, you have to completely fix it in this form, right? And maybe Algebra 1 kids aren't the best at it. But you're right, it is much easier to graph. A pretty accurate graph. But I don't know the answer to that. I think because sometimes Algebra 1 teachers are scared. Not always, but sometimes it seems kind of scary. So I told you every section we're going to practice something with square, because all of these conic sections have a perfect square in them when you write the formula. So the only other thing that could happen with this is, what if they give you an equation like this? You cannot find the vertex and all that stuff if it's not in the right form. So when I look at this and I see y squared, I know that I have to have y minus k squared. So if I see y squared and a 2y, just like with the circles we did yesterday, I know I have to complete the square. So I know just from looking at this, and so what you're going to want to make sure you know, by seeing y is squared and x isn't, like I know I want the equation y minus k squared equals 4p times x minus h. Which means I'm going to complete the square with this, and I'm going to shove all that other stuff to the other side, and I'm going to make it look like this. That's probably why, the real reason. Probably the other reason is that in Algebra 1, you don't usually do vertex form, right? It's always in standard form, and so you have to get into vertex form first. So y squared minus 2y, I'm going to leave the spot. I'm going to move that stuff over, so that's going to become negative 4x plus 11. Half the middle number and square it. So half of negative 2 is negative 1. Squared is positive 1, which means I'm just going to add 1 over here to 11. So I get y minus 1 squared. Half of negative 2 is negative 1. Over here I get negative 4x plus 12. Does that look like this? Close. This side should have parentheses, right? You always have to have x minus h, even if there's just a 1 in front. Like, so you want to factor out if there's any common factor here, right? That's going to give you your 4p. So if I factor out negative 4, that would make that x minus 3. So you always want to make sure you factor out any common factor that's there. Now that looks like my form of the equation. Here's where you want to be really careful. I always screw this up, and I always want to say my vertex is at 1, 3, because I read just the first one and the second one, so you see how that's wrong? You see on that? Right? It's not 1, 3, because h is with x and k is with y, so you got to be really careful that your vertex here is really 3, 1, h, k, right? I always messed that up, and then I think I've made a perfect graph, and then it's opposite what it is. Also, since y is squared and x isn't, that's left or right. Because that's negative, I know it should be opening back to the left. So in my head, I always think that first. Some people use the negative p to help them, because if p's negative, they go back p units. But it always helps me to think which way it's going to open. So 3, 1, that's my vertex. What's p going to be in this problem? Yeah, because it's just 4p equals negative 4, right? So p equals -1. So that means that my focus, because it's left to right, my focus is just back 1 unit. My directrix, if you want to graph it, is the opposite way. And remember, it's always a line. But if you don't graph the directrix, it's okay. When they make you list it all, it always helps me to actually graph it, because then I just take the information from my graph. And this one's going to be a lot thinner than our last ones, right? Because my focal width is just 4 now, which means I'm just going to go up 2 and down 2. So here's my vertex through my focal width, opening to the left. So let's see, my focus. Again, you can just read your graph if you understand how to graph it there, but I just moved back 1. So that's going to be 2, 1. My directrix is the line x equals the other way, right? So 3 plus 1 would be x equals 4. I think that's all I have to say. But again, I feel like graphing these is a lot less tedious than some of the other things that we had to graph if you understand how to find that p-value. Ready? And again, I haven't went back and looked at those equations once. It's not that I have them memorized. Like, I'm always like, k minus p, h minus p. Like, it's always confusing for me to think about all the formulas. It's not confusing when I just think about moving units and think about which way to open. So I really want to encourage you to do that as well. So your homework is kind of just a big hodgepodge of questions, trying to give you a variety here. And love to spend like 2 days on all of these sections, like 2 days on parabolas, 2 days on ellipses. But we're just kind of in the home stretch here, and with AP testing, we just don't have the time to do that. So I'm trying to give you some examples with some graphs. 7 through 10 are matching the graph with the equation, which should be really easy because one opens up, one opens down, one opens left, one opens right. Kind of get used to that. And then 31 and 34 are graphing. 49, 52, you have to complete the square. And then 67 and 70, I think, are multiple choice. So I think there's just 2 graphing ones on here, maybe. Yeah, I think there's just 2 graphing. If you have room on your graph paper from yesterday, you're welcome to use that. I have it like I have lots of just regular graph paper. Yeah. I think I just have this like tomorrow we will not be doing anything, but Friday I am having a worksheet, so I will have that worksheet ready on Thursday. And if you know you're not going to be in here on Friday, you need to get that on Thursday, or you can come and see me Friday. Friday's April. No, it's so about half. Yeah, I mean it's a worksheet day, so we have like